everybody. Today we're looking at the section 2.8 homework. So we're doing work with algebra of functions and function composition. So start with problem 9. So we're doing f minus g of 3. So f minus g of 3 would give you the same values of f of 3 minus g of 3. So if I put 3 into the f function minus 2x, I get minus 6. If I put 3 into the g function, what's absolute value of x plus 4? So that would be absolute value of 7, which is 7. Minus 6 minus 7 is minus 13. 11, f times g of negative 1 is going to give you the same values, f of negative 1 times g of negative 1. So f of negative 1 is positive 2, g of negative 1, so that would be negative 1 plus 4, which is 3. F's value of 3 is 3. 2 times 3 is 6. Let's go 13. G plus h of 0. So g plus h of 0 is the same as g of 0 plus h of 0. So if I put 0 into the g function, f's value of 4 is 4. If I put 0 into the h function, I would get 1 over negative 3, which is negative 1/3. So how do you add these? Well, I'm going to get a common denominator here and say 4 is the same as 12/3, because 12 divided by 3 is 4. So 12/3 plus a negative 1/3. 12/3 minus 1/3 is 11/3. Let's check out 19. Let's build some functions. So I want to create the r minus p function. So r is just minus 3x. And if I minus the p function, don't forget to distribute that minus across both terms, minus x squared minus 3x. So I got a couple things I can combine here, really just one thing. So minus x squared and then minus 6x. The domain of this function is, well, both functions to start have domain all real numbers, and this has all real numbers, so the domain is all real numbers. Ooh, let's check out 35. So let's do a little difference quotient here. Okay, so again, first thing I need to do is find the f of x plus h value. So if I put that into x squared plus 4x, I get x plus h squared, and if I FOIL out x plus h squared, I get x squared plus 2xh plus h squared, and then plus 4 parentheses x plus h. So don't forget to distribute that 4 to both the x and the h. So 4x plus 4h. Now it's all of that, all of this here, minus f of x. So f of x was x squared plus 4x, so it's minus x squared minus 4x. Those two things cancel out with those two things. So I'm just left with 2xh, h squared, and 4h all over h. I can factor an h out of all three terms and cancel it, leaving me with 2x plus h plus 4. Bam, done. Okay, let's check 47. Okay, so 47, let's do some function composition. So 47 is f of g of 8. Okay, so the first thing I need to do is g of 8. I'm going to put 8 into the g function, root 2x. That's root 16, which is 4. So this g of 8 is equal to 4. Now I'm going to put that 4 into the f function. So that's going to be 4 cubed minus 4 times 4. So that's 4 cubed is 64 minus 16. That's equal to 48. 55. Let's check it out here. Okay, so h of f of negative 3. So I'm going to first plug in negative 3 into the f function. If I plug negative 3 into the f function, I get negative 3 cubed. So that's negative 27. Negative 27 plus 12 would be minus 15. Negative 15 is going to go into the h function. So that would be 2 times negative 15. That's negative 30 plus 3 is minus 27. Okay, 65. Let's go check that one out. Okay, so I have a bunch of functions, and I want to find the new composed function and its domain. Okay, so n of p of x is number 65. So the p of x function is this parabola here. I'm going to put this parabola into the n function. So n is just a line. So I'm going to replace the x in n of x equals x minus 5. I'm going to replace the x with the entire p function. So that would be x squared minus 9x minus 5, which just becomes x squared minus 9x minus 5. Now, in order to determine domain of a composed function, you have to first look at the restrictions of the domain on P, because if it can't make it through P, it can't make it to the final game, and then you check the domain of the overall final function. So looking at p of x, that's just a parabola, so no restrictions on the domain, all real numbers. I look at this final parabola. This is still a parabola, no restrictions on the domain. The overall domain is all real numbers. Let's look at 66. So 66, p of n of x. So again, doing this in the flip order, let's look at these two together. So in this case, I'm going to take the n line, x minus 5, and I'm going to put that into the p function, the parabola. So I'm going to replace every x in x squared minus 9x, replace every x with an x minus 5, the n function. So I have to FOIL this out. This is x squared minus 5x, which is minus 10x, plus 25. And then don't forget to distribute this minus across both terms. Minus 9x plus 45. This simplifies to x squared minus 19x plus 70. So if you look, again, these are different. So n of p of x is this. This is putting the parabola into the line. And then this is p of n of x, putting the line into the parabola. Two different functions. The domain for this one is going to be all real numbers as well. Check 91. Okay, find two functions. So we're going to decompose for this 91 here. So we know our final function is x plus 7 squared. So I'm going to rewrite this as f of g of x. So it's like, okay, what's the inner function and what's the outer function? Where if I compose them, I'll create this. There's always lots of ways to do this, but I'm looking at this inside thing, x plus 7. What if I called the inside thing x plus 7, and then the outside function is the squaring? So I call this g and this f. So if I put this in for x, I would create x plus 7 squared. That's how decomposition works. Look for an inside function inside another function. In this case, it'd be a line inside the squaring function. Okay, 99. So we're given two graphs, and we're just doing a bunch of problems with these two graphs. So again, the first one is f plus g of 0. So f of 0 is 3, and then the g of 0 is minus 2. So 3 minus 2, or plus or minus 2, is equal to 1. G minus f of 2. So the g of 2 is 0. F of 2 is 1. So 0 minus 1 is minus 1. Okay, this is multiplication, not composition. This is composition, this is multiplication. Closed little circle. G times f of negative 1. So g of negative 1 is negative 2. F of negative 1 is positive 3. Negative 2 times positive 3 is minus 6. G divided by f of 1. So I look at g at 1, and I get it's equal to negative 1. G of 1 is negative 1. F is equal to 2. So this should be negative 1/2. Make that a negative 1/2 for that one there. E, f of g of 4. So g of 4, I put 4 into g first. So 4 goes into g, I get 1. And then f of 1 is equal to, let me see if I did this right here. So f of g of 4. So g, 4 goes into the g, and I get negative 1. I'm sorry. 4 goes into g, and I get negative 1. Oh, no, I'm sorry. I'm looking at the wrong point here. Let's do this again. F of g of 4. 4 goes into the pink graph, g, and I get 2. And then f of 2 is equal to positive 1. There we go. So 4 goes into g, and I get that purple graph 2. And then the 2 goes into the blue graph, and I get 1. So g of f of 0. So 0 goes into f. So 0 goes into f, and I get 3. 3 goes into the g, and I get a positive 1. Let's check this last one. G of f of 4. So 4 goes into f. So 4 goes into the blue graph, and I get negative 1. And then g of negative 1, negative 1 of the pink graph, gives me negative 2. So hopefully you had fun with these problems. I'll see you guys next time in class. Take care, everybody.